Okay, so we're going to begin lesson 2.4, operations with scientific notation. And our essential question today, how do you add, subtract, multiply, and divide using scientific notation? So here I have our answer. Oh, but it doesn't look very good, does it? There we go. To add or subtract, rewrite the numbers to the same power of 10, add or subtract the multipliers, and rewrite in scientific notation. To multiply or divide the multipliers, multiply or divide the powers of 10, and rewrite the answers in scientific notation. Now those, of course, that's the response to the question, but it's probably a little bit more easier understood once we start solving the problems. And we are on page 51. Okay, adding and subtracting with scientific notation. So we have a table for example 1. It shows the population of the 3 largest countries in North America, the United States, Canada, and Mexico. The populations for each country are shown, and that was in 2011. It says find the total population of these countries. So what we want to do is write them all with the same power. So you can see the United States has a power of 8, Mexico has a power of 8, and Canada has a power of 7. So let's rewrite Canada's number so that it also has a power of 8. So what we're going to do is take our decimal point, move it 1 space to the right, add 1 to the 7. So now we have 0, 338 thousandths times 10 to the 8th power. So all of them have a power of 8 now. And since they all have a power of 8, you want to add the multipliers. So that's going to be 3 1/10, 338 thousandths, and 1 1/10. So let's write those down. Keeping in mind that when you add up decimals, you always line the decimals up. Okay, so add those together. You'll have 8, 3, 5, and a 4. So take this, 4 538 thousandths times 10. Remember we made them to the 8th power? Keep your 8th power. And that would be your final answer. That's the population of all these countries together. So that's one way to solve this problem, by just using the numbers in scientific notation. Let's look at another one. Okay, so here's the same problem. But this time, what I want to do is solve the problem by taking each of these numbers in scientific notation and writing them out in standard form. So let's take the United States one. You're going to move your decimal point 8 spaces to the right. So we'll go past the 1, and then we'll have to have 7 zeros after it. So go past the 1, and you'll have 1, 2, 3, 4, 5, 6, 7 zeros. Okay, now we have the Canada number. So you're going to go 1, 2, you go 2 past the decimal. That will leave you with 5 zeros to put on. So this one is going to start here. 3, 3, 8, 1, 2, 3, 4, 5. Notice how I'm lining these up. So the zeros are on top of each other, so they're all lined up. And the last number for Mexico, that had the same power as the United States did. So this one's going to be below the United States 3. So it'll be 1, 1, 1, 2, 3, 4, 5, 6, 7. Add them all up. You get 0, 0, 0, 0, 0, 8, 3, 5, 4. And then locate your decimal point, move it all the way over. That was 1, 2, 3, 4, 5, 6, 7, 8 decimal places. So 538 times 10 to the 8th. You get the same answer. So either method will work. I caution you with this one though, because writing down the proper number of zeros can be a little confusing. I kind of like the other way better, the one where you use scientific notation. You keep the numbers, you keep all those zeros out of there. Okay, so we're on page 52 now, and you can see that we have that same table because in the your turn problem, it refers back to this table again. Using the population table above, how many more people live in Mexico than in Canada? Write your answer in scientific notation. I'm going to solve this using the scientific notation numbers. I'm not going to change them. We're going to use Canada's number and Mexico's number. How many more people live in Mexico than Canada? I hope you know what operation to use. Pause here. Okay, so what I did is I converted the Canada number into the power of 8 because that's what Mexico has. We did this before by simply moving the decimal point 1 space to the left and adding 1 to the 8 because I moved it 1 more space. I had only moved it 7 spaces before, now I moved it 8 spaces. Once I have these powers the same, I take their multipliers out front. 1 and 1/10, take away 3 and 338 thousandths. I subtract and I get 762 thousandths. So I wrote that down in scientific notation, but this is wrong. This decimal point's in the wrong space. So I have to move it back where it came from, take it 1 space to the right. I moved 1 space back, so take 1 space away from the 8, and this is my final answer. So I know many of you still want to make those numbers with all the zeros, which you can do that. But if you don't get those zeros lined up correctly, it's going to be a problem. So please make sure that when you do these problems, the final answer is in scientific notation, just the way it asked you to. Okay, so now we're going to be multiplying and dividing with scientific notation. So multiplying and dividing. And we're still on page 52. When the sun makes an orbit around the center of the Milky Way, it travels 2 and 25 thousandths times 10 to the 14th kilometers. The orbit takes 225 million years. At what rate does the sun travel? Write your answer in scientific notation. So we want to figure out the number of kilometers per year that the sun travels around the Milky Way. So they want you to set up a division problem using this formula, rate equals distance times time. So you're trying to find a rate. So the distance is here. That's your distance. Your time is here. That will be your time. So the rate is what you're trying to find. Kilometers per year, that is the rate. So let's work this out. You're going to take 2 and 25 thousandths times 10 to the 14th, and you're dividing it. I'm going to have to convert this into scientific notation. So that would be, let's see, 225 million. That would be 2 decimal point and 25 hundredths times 10 to the 8th power. So if you have one number in scientific and one in standard, you want to make them both the same. And I made these both scientific because it is easier. So what you're presented with now are actually two problems. You have this set of problems you're going to divide, and this one that you're going to divide. So with your handy dandy calculator, 2 and 25 thousandths divided by 2 and 25 hundredths is going to equal 9/10. And use your rules for the same base with exponents and you're dividing. You subtract. 14 take away 8. Well, that's going to give me 10 to the 6th power. Now this said to write my answer in scientific notation. This is not scientific notation. You see, this decimal point's in the wrong spot. I've got to push it over. So I have to push this decimal point back to the right. And when I come to the right, I have to take 1 away from that exponent. So now I have 9 times 10 to the 5th power kilometers per year. Okay, that's how you solve it. Okay, so this is just an additional problem. This one is not found in your book, but I want to try another one. When Neptune makes an orbit around the sun, it travels about 282 hundredths times 10 to the 10th kilometers. Neptune travels at a rate of about 470,000 kilometers per day. How many days does one orbit of Neptune take? Write your answer in scientific notation. Now, on the previous problem, they gave us rate equals distance divided by time. Oops, not Tim, time. So this question asks, how many days? So does it want rate, distance, or time? Yes, this one wants time. You're trying to find time here. So it kind of makes it awkward. And you should be able to figure out how to manipulate this formula. This should have been back from 7th grade using this formula. And perhaps you saw it more as distance equals rate times time. And this might be easier for you to use. distance equals rate times time. So we're going to find t. This is the one we're going to keep. So we need our distance. So which one of these numbers is the distance? Well, this says rate, so this is going to be my rate. This is going to be my distance. How far it traveled, that's my distance. So this number is going to be my distance. So that's going to be 2 and 82 hundredths times 10 to the 10th power. And that's going to equal my rate. Well, here's my rate. And I'm going to make this into scientific notation. So that's going to be 4 and 7 hundredths times 10 to the 5th power. So 4 and 7 hundredths times 10 to the 5th power. And I'm trying to find t. So you divide both sides. This is just like you're solving an equation like you did last year. Okay. So with my handy dandy calculator, I'm going to divide those two. And that's going to give me 6/10 times. Now I'll take care of these two. Remember, you subtract the exponents. Tilde on me. And so your final answer will be 6 times 10. Because you had to move your decimal point one space to the right, you're going to add 1 on to the 5. So that's going to be 2 to the 6th power. And how many days? That's how many days. I know you're going, this is crazy. This is so difficult. Well, keep in mind that you're just doing one piece at a time here. You're doing those multipliers out in front of the scientific notation numbers, and then you're doing the powers separately. And the reason why we learned the rules in section 2.1 is to understand how to use the powers. That when you're multiplying the same base, you add the exponents. When you're dividing the same base, you subtract the exponents. That's why we learned all that now to use with our powers of 10. So it's your turn now. This is on page 53. So please try these. I know it's possible you could make a mistake, but I guarantee you it's not the end of the world. If you don't try, you don't learn. Pause here. Okay, so I'm not sure what I was thinking. I had both of these on the same page, and I'm like, oh yeah, I'm gonna be able to fit them. So I gotta fix something here whenever we're done. So anyway, problem number 2. So again, you have a distance equals rate times time problem. You're trying to find the distance. So this is the rate. And it tells you right here at a speed of miles per second. When you have something like miles per second, feet per minute, anything like that, that's the rate. That goes in the rate spot. These are multiplying together. The time, seconds is time. So here's your time. You're going to multiply the front part. So that's what I got when I multiplied the front part, the multiplier. You're going to multiply those base 10s. When you multiply the base 10s, you add the exponents. That gives you 10 to the 8th. So that would be miles. Okay? So hang on a second and we'll try number 3. Okay, so on this page, I'm going to try number 3. So I just make sure you could see it again. So give this one a shot. Looks to me like they're going to give us travels at the speed, miles per minute. So this is the rate. They're going to give us the R. And the distance are giving us D. So how long does it take? You're trying to find time on this one. So remember, it's distance equals rate times time. But you're trying to find time on this one. You're going to solve for t. So once you get the number for distance and the number for rate in here, you'll divide both sides by the rate, and that'll give you the time. So it looks like you'll be dividing. Again, you solved these problems last year. They might have looked something like this. 12 equals 2x. You're trying to solve for x. So then you would divide both sides by 2, and you get x equals 6. That's the same idea here. You'll be putting some numbers in for D, for R. You'll divide both sides by R, and then solve it. Alrighty, so here's my distance equals my rate times my time. I'm going to solve this and divide both sides by my rate. So these two cancel. Time is by itself. So I solve this part of the problem, divide it with my handy dandy calculator. I rounded this to the nearest hundredth because this was a long decimal. And then whenever I divide with powers of 10, I subtract the exponents. 9 take away 7 gives me 2. So that's about how many minutes it would be. How long does it take the sunlight to reach Pluto? That's about how many minutes it would take. Okay. All right, so here's example 3. The table shows the approximate areas for 3 continents given in square meters. So we have Asia, Africa, and Europe. And here's their areas in square meters. Now, to measure continents, you necessarily wouldn't use meters. That's kind of small. You would use kilometers. And so rather than measuring it in feet, like we're used to in feet, we would measure something in miles. So rather than measure in meters, because that's about 3 feet, you'd want to measure in kilometers. That would be more appropriate. So what is the total area of these 3 continents? So let's solve that first. So the total area would be found by addition. So I want you to add these numbers together. Now when you add or subtract, look at your exponent. They should all be the same. If they're not, make them all the same. In this case, we're lucky. They are all the same. So add up all your decimal parts, the multipliers, and then keep 10 to the 13th power. Okay, so far what I've done is I've put down the multiplier for Asia, Africa, and Europe. And since I had this empty space, I just threw a 0 in. Then I added straight down. Remember to line up your decimal points when you add or subtract. So that gave me 8 4600ths. I'm going to go times 10 to the 13th power. Okay. Now, they also want to show you something different here. They want to show you how to use your calculator to do a problem like this. So over here on the right, whoops, you'll see that I have my calculator, and I wish I didn't put a green line on it. So let's take the green line off. There you go. So here's my calculator. I'm going to make it go big. Okay. Not too big though. And then I'm going to bring this to the front because otherwise there's a bunch of writing over top of it. Let's arrange this, and I want to bring forward. There we go. Okay, sorry about that. Alrighty, so what I want to show you in here on your calculator, and I'm not sure what yours looks like, but on my calculator, I'm looking for this E. On this one, it has a double E. And why I'm pointing this out to you is you are able to use calculators to solve these problems. So you would write these problems into the calculator like this. 4 4/10. You would press your E button and then put in 13. Africa would be 3 2/100. You'd have to press that E button and then 13. Europe will be 1 400 E 13. And then you would add those together. And that would give you 8 46/100 times 10 to the 13th power. So they want you to be able to put these E's into the calculator. Now, what calculator you have, if there's an E on there or not, I have no idea. But as I said, these are the ones we have in school. Whoopsies. These are the ones we have in school. And so if we were in school, you would, of course, be using these ones with the E's. Okay. I know it doesn't make it any easier. Okay, so on this your turn, what you want to do is take this number and write it in what's called calculator notation. So in calculator notation, you remove the times, you remove the 10, and in its place you put the E. And then you take the power and you write it on the end. And then for 7, 8, 9, they want you to write them using scientific notation. So what you want to do is remove the E, put it times and a 10, and this last number becomes the power. So give that a shot and we'll see what it looks like. Alrighty, so I came up with 7 5/10 E 5, 3E -7, 2 7/10 E 13. And then down below, 4 5/10 times 10 to the -1st, 5 6/10 times 10 to the 12th, and 6 9800 times 10 to the -8. I did do some guided practice problems too. So if you have to look through more, get more problems, try more, they'll be there too. Thanks, guys.